Alright, this is chapter 18, problem number 14. Calculate the power delivered to each resistor in a circuit shown in this figure, this diagram. So, the first step we need to do is take these resistors and kind of make it one. And for that, it would look like this. For these resistors, we'll say the same, but this will be, since it's parallel, the equation is R total equals 1 over R1 plus 1 over R2. This would be R1, and this would be R2, it doesn't really matter. So it would be 1 over 1 plus 1 over 3. From that, you get 0.75 ohms. So now we have these in series. So we can be represented as one resistor, and the formula for resistors in a series would be the sum of all of these. So 6.75 ohms. And then next step from there, we need to calculate, we need to calculate the current produced by the circuit. So V equals IR, EMF equals the current times the resistance. And we know the resistance here is a total of 6.75 ohms. So plug that in. And you need to find I. So to isolate I, it's just I equals V over R, which is in the volts, amount of volts is 18, is shown up here, over resistance, which is 6.75 ohms. Put that in calculator, you will get about 2.7 amps. And we know that the current in this place, in this part of the circuit, and this part are the same. So we can use the power equation to find the current. P equals IV also equals I squared R, which is more applicable for this case. So 2.7 amps squared times the resistance for this part, which is 4. That equals 14.2 watts. And you can do the same thing for this one, the end, because we know that it's going to be the same current here. So this is the fourth one. So P4 equals I squared. Sorry, my battery keeps running out, but this equation is actually, it should be 2, or this one should be 28.4 for the 4 ohm resistor, and 14.2 watts for the 2 ohm resistor. And then from there we can break it down. We find the voltage for these two, which is V equals the IR, and that equals the amount of amps times the resistance. 0.75 ohms is the resistance, and the current is 2.7 amps. Multiplied together, and it's 2 volts. Now we can find the power going to the third resistor, which we'll call the 1 ohm resistor up here. And for this we'll use V squared over R. And we just found the amount of volts, so it's 2 volts squared over the resistance, and it's 1 in this case, so it's just 4 watts. For the fourth one, V squared over resistance equals, it's 2 volts again, but it's over 3 ohms this time. So 4 over 3 is 1.3 watts, and now we found the power for all for the resistors.